Hi guys, welcome back to uniAssist's second video for tutorials. This time it's going to be on conservation of momentum. So our question here is, a man and a cart have a combined mass of mmc, what we're calling mmc, of 200 kilos. The man stacks 3 bricks, each with a mass of 2.5 kilos. The man and the cart system are initially at rest. The man throws the brick one by one out of the cart at a velocity of v is equal to 1.83 meters per second relative to the cart, and we are ignoring friction. So first question is, what is the speed of the cart and man just after the first brick is thrown? So what I like to do initially is draw a diagram to define my system, my velocities, my masses, just to keep that as a constant throughout the entire question. So I'm just going to start drawing a rough diagram. So we've got a cart with a man, and he's stacked 2 bricks, and he's going to throw out 1 brick with a velocity of v brick is equal to 1.83 meters per second. The total system is the mass of the man, and the cart is equal to 200 kilos. And each of these bricks have a mass of 2.5 kilos. So, like I've mentioned in our previous video, next step is to define your coordinates. So, I'm only considering the x direction in this question because I don't have any movement in the y direction. So, just for my sake, I'm defining the x direction as this direction here. So this will be our positive x direction. Next thing I like to do is just have my significant figures in check. So I've got mmc as 200 kilos, I've got mb as 2.5 kilos, and I've got vb as 1.83 meters per second. So my lowest significant fig is given by my mb, which is 2 sig figs. 2 sig fig. Therefore, my answer is going to be in 2 sig figs. We'll just keep that to the side. So, what do we do in these kind of momentum questions is we decide what's happening to our system. So, initially we will have a momentum, and we'll have a momentum final after the man throws the brick out. But in total, because we don't have any other systems acting on our total system, our total momentum change is going to be 0 because we are conserving momentum. So the momentum of the initial system and the momentum of the final system with the man, the cart, the remaining bricks, and the cart will be equal to the momentum of the brick that is thrown out. So what I like to do is write as such. So my P initial is equal to my P final. So my P initial is 0 because as we look at the question, it says the man and the cart system are initially at rest. So that includes the man and the 3 bricks before he throws it out. So that's equal to 0. My P final is equal to my P man and cart system plus the 2 bricks. So it will be P MC plus 2 times the bricks plus my brick that has been thrown out at that velocity. And we can simplify this as, so the general momentum equation, I'm sure you know, is P is equal to mv. So that's just my general equation. So now this is equal to mmc plus my mass of my 2 bricks, because we've got 2 of them, multiplied by the velocity of the system, which we'll call Vf, plus my mass of the brick that I'm throwing out, multiplied by the velocity of the brick. So in total, we've got mass MC, which is 200, plus 2.5 times 2, multiplied by VF, which is what we're trying to figure out, plus MB, which is 2.5, times by VB. However, as you noticed here, my VB is 1.8 meters per second, and it's in the negative x direction because I've defined my positive x direction to be moving to the right. So don't forget that, but it's minus 1.83. I can even go back and put a minus sign in front of this here, just to make it a bit clearer that it's going in the negative x direction. So what does that give us? VF is equal to 0.022 meters per second if you want to keep it at 2 sig figs, because if this is in a quiz or an exam paper, they will want you to put it into the correct sig figs. And remember also that it's in the positive direction, so it's moving to the right if they ask you what is the direction. But remember that if you are using this answer to calculate something else, you keep the total significant figures that you use to calculate in your calculator, so keep sig figs, because you want to keep your answer accurate. So you can store in your calculator using the answer button, or you can use the STO in the Casio calculators, which everyone normally uses. Second question is, what is the speed of the man in the cart after the second brick has been thrown? So I've written our conservation of momentum equation here again, which is important to remember. So it's P initial is equal to P final. So it's equal to the momentum of the man cart system plus the 2 bricks that we had on the cart. And our final momentum is the momentum of the man cart plus 1 brick plus the momentum of the brick that he threw out, the second brick that he threw out. So then that's equal to M of the man cart system plus the M of the 2 times bricks multiplied by the VF that we defined above. That's the same V, which is equal to the mass of the man cart system, plus the mass of 1 brick multiplied by the speed, the second speed that we will call VF2, plus the velocity of the brick, the mass of the brick, multiplied by the brick velocity. So now our left-hand side equation is once again 200, that's what we had before, plus 2.5, and we have 2 of them, and then multiplied by the velocity we calculated before, so 0.022, but remember to store that, use the stored value in your calculator. That equals the man plus cart system plus 1 brick, so 2.5, multiplied by VF2 plus your brick, multiplied by your VB. However, just as a reminder, our VB is a negative number, so multiplied by negative 1.8. 3. And now we're solving for our F2, so our final velocity, and that is equal to 0.045 meters per second in the positive direction, so it's moving to the right. And that's it for this question. Thanks for watching the video. Don't forget to like and subscribe the channel, and also like our Facebook page, and please leave any comments about feedback on the videos and if you'd like us to do any other questions.